the denominator is 5 to the 2n, times 5 to the negative first, because when you multiply two things with the same base, the powers add. So we get the sum from n equals 0 to infinity of n plus 1 over, we can factor out that 1 over 5 to the negative first. This is 5 to the 2n. And then next, that's 5 to the 2n, or you could say 5 squared to the n. So that's 5n equals 0 to infinity n plus 1 over 25 to the nth. And then trying to make it a little bit neater, we could change it so that instead of having n plus 1 on the top, we could just say n if we start summing at n equals 1 instead. So look, they're equivalent series because we still have 1 in the top and we need to have a 0 possible in the bottom. So we've got that now in the denominator. So we made it neater. We got rid of the n plus 1, we got rid of all the exponent business up here, and now that we've made it neater, we can see that it's representing a form that we've seen before for a geometric series. This is n, and this is 1 over 25 to the n minus 1 power. That's what the denominator is, right? So that's a geometric series. So we know that the sum of a geometric series, okay, so this looks kind of similar to a known Maclaurin series. That's why having that table of known Maclaurin series next to you while you do homework or a test is helpful. Sum from n equals 1 to infinity of x to the nth power is 1 over 1 minus x. Look, this is kind of close to this. If we were just to take a derivative of both sides, then we're going to have the sum equals n equals 1 to infinity. That's n times x to the n minus 1, because n is a constant. And the derivative of this side, if you work it out, is going to be 1 minus x squared, because that's x to the negative first, and then because of the chain rule, the negatives are going to cancel each other out. So this side right here is close to this side. Instead of x, we got 1 over 25. So if we want to find the sum of this series, it's saying the sum is equal to this function. So all we have to do is plug in 1 over 25 in for x and simplify. So that's 1 over 24 over 25 squared. So that's the same thing. Oh, and I forgot my 5. I'm sorry. So look, this whole series, we could make these equal to each other with a 5. Sorry, I dropped that 5 that we factored out. Okay, so that's 5, and then flip that fraction. That's 25 over 24 squared. That's the exact answer.